discoveries in chemistry led to a better understanding of atomic structure? Question 1.1. Atoms were originally thought to be spheres that could not be divided. The plum pudding model of the atom was then developed. Figure 1 represents the plum pudding model of the atom and describe the plum pudding model of the atom. 2 marks, roughly 2 minutes. And the plum pudding model of the atom will be a ball of positive charge with electrons embedded. 1 mark for a ball of positive charge and 1 mark for with electrons embedded. Question 1.2. Atoms contains electrons, neutrons, and protons. Write these 3 particles in order of their discovery, earliest to latest. For earliest, you have electrons by J.J. Thomson in 1897, followed by the protons by Ernest Rutherford, who is a student of J.J. Thomson at Cambridge in 1917 to 1920, roughly 1919. Followed by another student, James Chadwick, is a student of Ernest Rutherford. He discovered neutrons in 1932, all from the same university, Cambridge. For question 1.3, very few atoms of the element tennessine, Ts, have ever been identified. The atomic number of tennessine is 117. We need to predict the number of outer shell electrons in an atom of tennessine. Give 1 reason for your answer. Use the periodic table. So we can use the periodic table. Here's our periodic table here. And we're looking at tennessine, which is 117. It's in group 7. What that meant is it would have 7 electrons in the outer shell. And the reason for that is because it's in group 7 and the valence electrons, which is the outer shell electrons, must be 7. The next question here will be for question 1.4, where we to describe tennessine was first identified by a small group of scientists in 2010 to suggest 1 reason why tennessine was not accepted as a new element by other scientists until 2015. This is to do with time peer review. So the time it takes for the peer to review the discovery is too long. Question 1.5. The discovery of isotopes explained why some relative atomic masses are not whole number. Element R has 2 isotopes. Table 1 shows the mass number and the percentage abundance of the isotope of element R. And we're to calculate the relative atomic mass AR of element R. And to give answer to 1 decimal place. So relative atomic mass equals the sum of the products of A mass number times the AB abundance, percentage abundance. And we need to divide them by 100 because the sum of these abundance must be equal to 100. And so the first part will be AR equal to 6 times 7.6 plus 7 times 92.4, and we need to divide that by 100, and that gives 6.924. But we have to write this in 1 decimal place. Because we're writing in 1 decimal place, we can write 6.9 grams per mole, and that will be 6.9 grams per mole.